Hello, today we're looking at question 5, the y-squared transformations. This is a practice. So similar to the previous video, where we had a set of data that was clearly nonlinear, which is, as you can see over there, and my arm doesn't go. It is a nonlinear data. It is nonlinear data. And the idea is that we need to apply a transformation to it to try and linearize it. Now, in this case, we are telling you to do a y-squared transformation on it instead. So in this case, remember that the x values are 0, 2, 4, 6, 8, and 10. The y values are what's above me right there. And we have to do a y-squared transformation. So same as how we did it for the previous question, we're going to go down to, on list 3, we're going to click down to Cal. And we're going to type list 2 this time. And we're going to raise it to the power of 2. And this is what we're going to get. Now, it's going to be all in fractions. That's fine because I have my calculator set to standard. And when your CAS is set to standard, it will always try and give it as a fraction. Now, if I was to do that as a decimal and I was to rerun that calculation, it changes it back to a decimal value. So we'll go with decimal. We'll go with decimal for now, and we're going to apply our transformation. So instead of doing list 1 and list 2 like this graph is currently setting up to be, we're going to go list 1 and list 3. So X list is still going to be list 1. Our Y list is going to be list 3 instead. We're going to hit set. We're going to graph it. And this is what happens. All right. Now that looks like a perfect straight line to me. But is it? But is it? So, regression, linear regression, list 1, list 3. Hit OK, and it comes up looking like this. Which is fine. It's not great. It's not perfect. I mean, the R value is 0.998846, so that's pretty darn close. Just out of curiosity, if I left that as a fraction, that's kind of the same. Cool. I was just looking to see whether or not the fractions and whether it was rounding or something, but it's clearly not. It's using the proper as many decimal places as possible. So now that we have this, we will go back to our whiteboard. So just gonna grab that, move that over here for a little bit, bring up my whiteboard. And on our whiteboard, so the question actually says, write the coefficients to 2 significant figures. 2 significant figures. So based on what I've got up there for my on my CAS, what are my 2 significant figures going to be? So it's y equals a plus bx. And it's saying A is 1.5019, blah, 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 blah. Well, 2 significant figures is 1.5. And B is going to be, so it's 3.09. Well, the 2 significant figures, that's just going to be 3.1. So our equation is going to be y equals 1.5 plus 3.1x. Now, similar to the previous one where I swapped out the x for x squared, what was the transformation that I was asked to do? It was a y squared transformation. So I'm going to swap out that y for a y squared. And that should be the equation that is given in the back of the book. Can I get a thumbs up in the chat if I'm correct? Thank you. So, now, the next question is, using this equation, so this one you're here, predict the value of y when x equals 9. This is where the challenge comes in, because it doesn't want the value of y squared. This gives me the value of y squared. It doesn't give me the value of y. So what I'm going to have to do is I'm going to have to do a couple of extra things to it. So y squared equals 1.5 plus 3.1 times 9, because it wants when x equals 9. So from here, I'm going to need to go back over to my CAS, because just let's face it, it's going to be quicker than me doing it in my head. Uh, 1.5 plus 3.1 times 9. 147 over 5. We'll change that to a decimal. 29.4. So we have y squared equals 29.4. That means y is going to be equal to the square root of 29.4. And it's going to give me a weird answer. That's because I'm still in standard, but if I press this button, it'll turn it to a decimal, and it wants my answer correct to 1 decimal place. So that's going to be 5.4. And make sure that if you're doing it, if you're putting in your own decimal places, you say 1 decimal place. And that should be the answer the back of the book gives you. That's why y transformations are a little weird, because you have to do that extra square root step. Remember that y squared and y are connected, but they are not the same.